Thank you, Joyce, for introduction. Good morning, everyone. My name is Tian Jing. Today, I'm very happy to see all of you online virtually in this Zoom webinar. In the next 1 hour, it's supposed to be our lunchtime, but thank you very much to still stay online with me for my talk. As you can see from my title of my talk, Stay Safe and Healthy with Computer Vision. Basically, in my talk, I will share with you a very interesting technologies, which is computer vision technologies, and how we can use these computer vision technologies to help us stay safe and healthy in public place, workplace, residential house, and everywhere. So in my talk, I have 3 parts. The first part, I will give you a very brief introduction and background to share with you what is computer vision technologies, what we can do using these technologies. So this part will be very useful for those audience without too much experience in these areas. In the second part, I will share with you some recent advances and use case in this new normal, how we can use computer vision technology to help us with these new normals. I also share with you some interesting project demonstrations which are developed by our ISS students. Finally, in the last part, I will have a few minutes to share with you what are the relevant courses offered by ISS NUS so that you can know where you can find the course to take a training and upgrade your skills. Before I share more details about the computer vision technologies, let me give you 2 motivations use case why we need to study and apply these technologies. The first example, there will be this virtual learning festival today. In your computer monitors, you can see my human bodies overlaid on top of my PowerPoint slides very nicely. But actually, in my studios, in my office, I stand in front of the green wall, which is the plain green color walls. Also, I have a DSLR digital cameras. Look at me, take a video about myself, do the video streaming in real time. So we need technologies which can automatically crop my human bodies in front of this green wall and overlay my human bodies with my slides nicely together. So computer vision technology can help us to do this job. The second example, as you can see from my slides, in this picture, there are 3 people, they are queuing outside the restaurant. All of them are playing the handphone games. So we need some technologies which can automatically do these inspections to make sure all these 3 people, they are following our social distancing rules. That means they stand 1 meter, at least 1 meter apart away. So again, computer vision technology can help us to do this job. Besides the 2 examples, I can share with you more motivation use case in many other industry sectors. For example, in the manufacturers, you have product factories. You assemble this in the iPad products. So you have some system can do the inspections on this iPad service to check whether there's any defect on this iPad service. So instead of deploy your staff to do these manual inspections, we can apply the computer vision technology to help us automate this process. Another example in the retail industry sectors, you are running the food store in hawker centers. You want to know how many customers visit your store every day. Who are these? Are they ladies, gentlemen? What is the age group of your customers? Are they a child, primary school students, young couples, senior, or even pioneer peoples? So based on all these information, you can optimize the business operations. For example, you can bring more bubble tea and milk tea for the ladies, bring more chicken wing, fish ball for the young child. Okay. So all these information are very important for optimize the business operations. Okay. So you see, computer vision is potential to be used in many applications. So the next question is, what is computer vision? So in my slides, I give you a quotation from this artificial intelligence expert who is a professor in Stanford University, who is a professor Li Feifei in one of her TED talk. So according to her definitions, computer vision technology is very important subset of artificial intelligence, which can analyze image and video data. So what we are doing, so this technology can help us recognize object, identify human people, infer the 3D geometrics of the image, and finally understand the emotions and actions of all these objects. So this is exactly what the human beings are doing and analyzing the image and video data. So for example, you can see from my slides, given this picture of these ladies. So as a human, we use our eyes. So our eyes carry two cameras with us, which is our two human eyes. So we use these eyes to look at these photos. Then based on the human decision making, we can analyze, oh, this is some beautiful lady in the pictures. So similarly, we can develop this computational process using the computer vision technologies. We use digital cameras to take a photo about this scene. After that, we run our algorithms and artificial intelligence engine in the computers to recognize, oh, this is a lady in the pictures. Okay. So basically, in summary, so computer vision technology can help us to analyze image and video data. There are a lot of information in this image and video data. So that's a very famous saying. So one look is worth 1,000 words. That means even for a single snapshot, you need to spend 1,000 words to describe the image contents. So the next question is, so where this the image and video data comes from? There are two major sources for this image and vision data. The first source, the image vision data coming from is a public surveillance camera. For example, in Singapore, if you go to the outside to take public transportations in MRT stations, there are a lot of cameras looking at this platform to make sure it's safety and safe. Okay. Also, if you drive the car on the highways, there are many other cameras mounted on smart lampposts to make sure your car follows some traffic rules. If you return to home after the work, your HDB lift is covered by the cameras, so managed by town council to make sure there's no loan shark appearing in this residential neighborhood. According to a recent study, I shared the link in my slides. Okay. According to these studies, so Singapore is ranked as the 11th most surveillance city in the world. So according to the study, for every 1,000 Singapore people, there are 15 camera looking at us. So I think it's good. So with all these surveillance camera, we can make sure this public space is safe and safety. Right? The second source for the image and vision data coming from the consumer electronic cameras. Okay. Almost all of us have smartphones. Some smartphones have more than one cameras. Many of us have more than one smartphones. So we use these smartphones, take photos, record the videos, upload the data to the social networks. Okay. So there will be a lot of data that waiting for us to do analytics. So you know in Singapore, so there is a very unique place of interest, which called the camera museums. So inside the camera museum, there are more than 1,000 types of different cameras displayed in this museum. Different types of cameras can give us different types of information so that we can analyze the image data. For example, the Euro RGB visible digital cameras can give us a natural scenes. The infrared cameras can help us to analyze the content for the high body temperature, such as humans, in these low lighting conditions. Thermal cameras can help us to do the temperature takings. You know, nowadays, every day we need to declare the temperature 2 times. So thermal camera can help us to do the temperature takings. Okay. So based on all this information, based on all these data of image, video data, so what can we do? We can do a lot of things. Okay. So the first thing, successful applications I share with you, which is this teachable machine. So teachable machine, this system is developed by the Google. So I share the website in my PowerPoint slide. Certainly today, I don't want to do the live demo from my side. So if you have time, if you're interested, you can try this website offline in your own laptop. So for this system, everything is running on the browsers. That means you don't need to install any additional plugin or software in your own laptop. Everything is running online and running in real time. Okay. So what can we do for these demonstrations? Okay. So inside this demonstration, we can do a lot of things. First one, we can do the image recognitions. So this system requires the access to our web cameras. So in front of the web camera, you can show different types of image objects. For example, I can show this is a PowerPoint controller. This is my drinking waters. Okay, I show different objects in front of cameras. I can train and teach this machine automatically so they can generate some AI model to help me to recognize the object automatically. Another example is I can show different posture in front of cameras. For example, I can raise up the right hand, raise up left hand. I can show number 1, number 2, or different sign language. So based on all this, the machine can run the AI engine behind to recognize my posture, recognize my actions. So as you can see, so far I give you many examples to show you the computer vision is very potential to address all these different interesting applications. So how to do this, right? How to do it? Since it's potential, but how to do this? Okay. So now I share with you a typical computer vision system pipeline. So in this pipeline, it contains the following sequential steps. Okay. So I will briefly go through all these steps one by one. So it's a sequence step. Okay. So for this system pipeline, it starts with the data acquisitions. So we need the data, right? Without the data, we cannot do anything. So we start the data acquisitions. So what kind of data we can acquire using these acquisitions? So as we explained earlier, so we can deploy different types of cameras to help me to capture different types of data. We have visible RGB data, we have infrared data, thermal data, or even the depth data to help me infer the distance between the object and the cameras. We need many data so that we are able to apply some supervised machine learning to train some engines. For the image recognitions, we can use this is a very famous benchmark image recognition data set, which is called ImageNet. So inside the data set, we have millions of images with manual annotations. So they already help me to label what is the image content, such as the laptop, is a car, is a human face. To recognize the action in the videos, we can use this activity net, which is another huge data set. So inside the data set, we have a lot of video sequence with a manual annotation to label what is the human action inside these videos. So now we have a lot of data. So what's the next step? Before we analyze the data, we need to do some pre-processing. So why we need to do that? Because the reason is in most time, the data are not good enough for us to analyze the data. So as we can see, garbage data in, garbage result come out, right? So before we analyze data, we need to apply some pre-processing. Particularly in this image data capture in the bad weather conditions. In Singapore, it's very often to have rainings. So for the photo capture in that rainings, we need to enhance the qualities. Also, in the nighttime, we'll capture the photos, so the image is very dark due to the low lightings. We need to enhance the contrast so that we can see the details and image object content very clearly, so inside the photos. So now the image quality is good enough for me to move to the further step to analyze the image contents. But instead of apply the raw image data, which is the color of the image, normally we will prefer to extract some features. We rely on the features, not the raw image colors. Why? Because color is very unreliable. For example, today I wear this blue color learning day t-shirt or ISS. It appears very nice blue colors. But if I off the light in my studio, also if I go to the outside, I think outside is very cloudy today, then my teacher will appear as a different blue colors because the color will change due to the different lighting conditions. So color is not reliable feature for us to analyze the data. So we need to have a more robust feature extractions from the image data contents. Okay. Then what's the next? Next is that we can do many other advanced vision recognition tasks. We can recognize the object, or this is the image, is a photo, this is a car. We also can detect, or these are two people in this place. There are another 5 cars and another 4 taxis in this place. Also, I can segment where is the location of this car in this place where monitors. I also can measure the movement and the speed of the car. I even can know whether they go to the left turn or right turn. All these informations are very important for us to make some decisions depends on our business applications. For example, I want to ask you, so how many people in this place? Is it very crowded? If it's more than 100 people in a political church, or if there are more than 50 people in a wedding event, so it's not allowed, right? So we need to enforce more security staff to stop this event. Okay. Then another question is, so where is the car in this place? Do they follow our traffic rule? Suppose the U-turn is not allowed in this place, so whether this car, they do the U-turn? If they do the U-turn, you can go to there to find this car, right? So this is all the typical business question we need to answer, and computer vision techniques can help us automate the process to make the decision automatically. So next, I elaborate a bit more details about the few 4 key vision recognition tasks, because all these 4, they are very important in the many applications. Okay, so you can see from my slide, this is a group of young talent photos. Okay, there are 2 ladies, 5 boys, in these photos. Okay, so based on these photos, we can do a few vision recognition tasks. First one, so what is inside? So what is inside? Is there any human inside? Is it so? What is weather inside? So we want to recognize the image content and add on some recognition result. It's so-called the tag, TAG. I want to add the TAG. Okay, this is very useful. So for us, we have we use a smartphone to take a lot of photos, but in the phone there are so many photos. Sometimes it's very difficult for us to search and find the relevant photos. For example, now I ask you, so when is your last photo in your last trip? Definitely it was in last year, right? Because this year we cannot travel. Okay, so there'll be very sometimes it's not very convenient for us to search a relevant photo in the phone because there's so many photos. So we can rely on the image recognition techniques to help us to recognize the content, add on some tag, TAG automatically. Based on tag, we can do the search and retrieval. Okay, so this is some example for the tag I can add on for this photo. We can add on the people, photography, friendship. Okay. The next question is, I want to know where is the object of interest? For example, given this is a group of young talent, so where is your girlfriend? Where is your girlfriend? Where she is sitting? Okay. So I want to know the location of the object of interest. So that's so-called the detections. I want to detect the object based on your predefined object list. Okay, so that's a requirement for this technology. You need a predefined list object, such as human face, your girlfriend's human face, such as a car with the car plates numbers. So you need to detect all these predefined objects in the image. And the output would be the location, which is the bounding box, including this position of how wide the box and how high the box. Then the next, I know your girlfriend is there. So how is the attribute? Attribute means what the t-shirt she wears, whether how is the facial expression of these ladies, whether she is smiling, happy, surprising, or angry. This is so-called attribute. I want to do the attribute recognitions based on the detected object. So the input will be my cropped human face. Based on that, I can recognize your expressions and add on some this attribute. Okay. Then lastly, I can recognize actions. Certainly in my slides, I didn't show you the video sequence. I only show you some static image. But based on static image, I can detect this is the skeleton key points. I can know the posture of these human bodies. Okay, so based on that, I can recognize action of the humans. Okay. So beside all these examples, computer vision is also very potential in many other applications. Okay, so in my slides, I show you some examples. I will briefly go through one. So we start with the row by row and column by column. Okay, so now we start with the first example, which is the top left picture in my slides. So what's inside in this picture? We can see a gentleman, he's riding a horse. Beside him, there is a dog. Then behind him, there's a car. Okay. So basically, we're running the object detection to detect, I know there's a lady, there's a gentleman, there's a horse, there's a dog, there's a car. Also, I can further apply such techniques on crowded place. For example, this is my second photos in the first row. So there are a lot of people that are gathering in front of these buildings. I can do this is the object detection to do a counting. How many people in this place? I also can do a more advanced way. I can carry the camera using my drone. So the drone is flying in the sky, take a video from the top views. Then based on the top view, I can detect the car, which is the green color bounding box I highlight in the third photo in my first row. So based on that, I can count how many cars in this place I monitor. Okay. So now we move on to the second row. Go on to second row. For the first example, in the second row is related to the image search and retrieval. So imagine you are a tourist. Okay, you go to the overseas place, you visit some place of interest, you take a photo, but you don't know where you are. You have no information about this place. So you just take a photo, send this photo to the Googles, then Google will search the relevant photo online. Also, they return you some relevant information about who is the founder, who built these buildings, what is some founding history about these buildings. So you can get all these information through by this image search. The second example in my second row will be the small autonomous cars. in the car, camera is one of the key sensors components for this autonomous car. Based on these cameras, we can sense our environment. So we know what's happening in this my environment. So how many humans in front of me and what is the distance, so I can make my decision and navigations. Okay. Then now we move on to the third rows. Okay, so in the first example, in the third row, I can see a set of pictures about these basketball players. I take this sequence, a snapshot about these players. So based on the player's posture, I can analyze whether he has correct posture or whether he has wrong posture to shoot this basketball. So this information can help me to improve the training. Next example will be the three-dimensional modeling for this building. It's very big buildings. It's very useful in the defense sectors. So I want to have a three-dimensional modeling so I can display the building in my command centers. So I can make some decision how my soldier can go in to do some rescue operations. So it's very important. Okay. So then now let's move on to the last column. So in the right column, I took example. Right? Okay. So in the top right examples, we can see ladies do the shopping in some unmanned shops. Then the lady pick up some his favorite snack and vegetables and drinks from the shelf. So based on the camera, we can recognize what the product she already purchased. Then at the checkout, I can recognize the face. I know this is the ladies. I can deduct the money automatically from the PayLah, from the GrabPay. So it's a cashless payment. In the last example will be bottom right is this example. That's be the computer graphics. I can use the computer graphics to generate some virtual object so I can display this virtual object in the movies. Last year, there was a very good movies about the Lion King, right? So Lion King is looks real. Then next month, I think we have another DC movie, The Mulan. It's a very famous Chinese history about these lady heroes. So we apply the computer vision technology to generate some virtual object, then overlay with real person together. So I think this will be very fun movies. Okay. So far, this is my first part. In the first part, I already shared with you a basic introduction about the computer vision, what is computer vision, and what we can do. So I hope you already have some ideas for your own industries, for your own organizations. Okay, so now let's move on to the second part. So in the second part, I will share with you some recent advances, how we can apply the computer vision for these recent new normal periods. Okay. So due to this new normal for this COVID-19, it already has significant change for everyone, for our working styles, social lives. Okay. So one of the most important change introduced by this new normal COVID-19 will be contact tracing. Certainly now, contact tracing is very popular. I think almost all of us have already installed the Trace Together apps. Inside the NUS campus, we have additional apps. I have 2 apps to make sure to do the contact tracing for myself inside the NUS campus. So we need to declare the temperature 2 times every day. So, but before this new normal, so contact tracing at least is not very popular as this, right? So particularly when the first confirmed COVID-19 case happened in Singapore, that was in January. It happened in some hotel in Sentosa. During that time, we don't have the Trace Together apps. Then how we do the contact tracing? So according to this the news interview videos for this hotel management, so this management clearly mentioned that they use the CCTV footage to help the government to do the contact tracing. So based on CCTV footage, they can figure out where the infected patients travel inside the hotel and who are the other people had a close contact with the infected people, including those the housekeepers, cleaners, reception staffs. So you can see the CCTV footage is very useful for us to do the contact tracing. But how? How we can do this? So we can rely on different features. So basically the idea is to track the same percent across multiple cameras because multiple cameras will install and mount it on different places. So my objective is to figure out the same percent across these multiple cameras. But how to track this same percent? We can rely on face, for example. If we can see the face clearly, then that's very straightforward. We can just do the face recognition, do the face matching, and know these are the same people. But if we cannot see the face, then it's more difficult. So we can rely on other features. For example, rely on the t-shirts. Today, I wear the learning day t-shirt. I think I will not change the t-shirt for this whole day, right? But I will travel around in my office, in my home, in my some shopping mall in the evening time. So you can rely on the learning day t-shirt to travel myself. Okay. Another example would be the bottom right image in my slides, which is a screenshot for some movies, which is the Mission Impossible movies a few years ago. So during that movies, this guy need to walk through this corridor. In this corridor, along the corridor, we have set the cameras to look at this posture, how this guy is walking through this corridor. Basically, we do the kit analysis to recognize whether it's people, authorized people or not authorized people. So in summary, computer vision technology can help us to do the contact tracing to track the same person across multiple cameras on multiple places. Second example, by monitoring. Okay, so in my slide, I can show you two interesting demonstrations. The first one is a robot dog. I think it's very famous. Okay, very famous now in Singapore. Okay, so for this dog, they will deploy the camera. So camera will help him to sense the environment. Also, the camera will do the social gathering detections, because according to our rule, if we have some gathering outside for exercise, we cannot have more than 5 people, right? So basically, they do the human countings. So they can, with the computer vision, they can help me to automate the process to do the human counting outside. Okay. In the second example in my slides, this is some company in the Americas. So they deploy the computer vision, they study this footage. Based on the finding is, due to this new normal COVID-19 period, the usage of bicycle is increased, significantly increased by 200%. So this information will be very useful for the government agencies so that they can allocate more resource for the bicycle riders and for the pedestrians. Also, they need to optimize the traffic management rules so that they can make sure this is the bicycle riders and pedestrians have more comfortable traveling experience in these cities. So in summary, the computer in the urban monitoring, so computer visions can help us automate some process to give us some information about how is the residents people's, what is their behaviors during this COVID-19 periods. Next example, vision in both service. Okay. So in this example, during this period, we still need to work, right? Although we work in home, but we still need to work in some place. For example, in some worker dormitory is a high-risk place. So we can deploy this robot. The robot will help us do the patrolling. Also, you can see this staff, they wear all this personal protection suit. Okay. So with this robot, right, so we can do this patrolling in the dormitories. Also, in my second example, in the bottom, I can deploy the robot to the hygiene cleaning in the warehouse. Okay. So in my office, I have a cleaner helping me do the cleanings for all these office furniture and classroom teaching equipment. You can imagine if there's some robots, they can help us do the cleaning. Okay. So the computer vision can help this robot to do the navigation themselves. So they can do the self-driving, so they can do the cleaning self-driving themselves. Then in the right example featured in my slides, you can see, I think this looks like the exhibitions, exhibition halls. So in the hall, so we have all these robots. The robot will talk to these foreign workers. They can help us to do some basic medical checkup. For example, I can measure temperatures, measure heartbeats. Also, the vision can enable these communications between the human and the computers. So in summary, this is some example of the service which are enabled by the computer vision technologies. Okay. Next example will be screening. So we need to have a fast screening to figure out once we have confirmed infected people, we want to know who is a close contact. So in the healthcare domains, so we can apply the computer vision techniques to help the doctor to make a faster screening, for example, based on the lung CT image. At the entrance of the building and the office, some primary schools, we can deploy such screening and scanning equipment so we can do the filtering for those visitors and staff with high temperature, we can block them. So stop them enter this premise. Okay. So in summary, so computer vision can help us to do these faster screenings. Next example, contactless access. Okay, so in this period, we try to avoid the physical contact. For example, even I see my new friends, I try not to shake hands with my friends to do this greeting. But we still have to press some physical button. For example, how you press a leave button? So according to this today newspaper, they share with us a few innovative ways to press leave buttons to avoid physical contact. For example, you can use a pen, you can use a power button controller, you can use your arm, you can use the two stickers, right? Two stick, okay. But with the help of the computer vision techniques, we can solve this problem with the contactless access. So you can imagine we have a speech recognition. I know you are the staff of this office. I know you are registered registered visitors, so I can open the door for you. You don't need to press any physical buttons. Even inside the lift, I can recognize the face. I know you are in level 2 company, so I will move you to level 2. Also, you can use the voice control. For example, you can see I want to go to level 4 meeting rooms. Then the lift will move you to level 4. So you can have this control, so you don't need to press any physical button. So in summary, this is the computer vision techniques can help us to do this contactless access. Okay. Next, working from home. So we need to working from home. At the same time, in ISS, we do a lot of the virtual learnings. So we do the virtual class. So, but do you still really online and focus online? Okay. So in my slide, I show you the two different generation product. The right figure, which is the first generation of this system. So this guy shows some static pictures in front of the cameras. So from the lecture view, he always says, this student is always focused, very focused in my class, okay? But actually, this is a static photo. In the left demonstration, which is the improved second generation system. So this student is very smart. So he showed this recorded video. So in the recorded video, he showed a different facial expression. Oh, he nod his head. It's very interesting. He recorded all these videos. So from the lecture point of view, he see this student is very interesting in my class. Okay, but as a lecturer, how we can detect such case? Okay, yes, computer vision we can help us to detect such case to make sure you are really focused online, really focused in my class and in my talk now. Okay, so it's about some example for working home. Next example, social distancing, okay, very unique. I think before this COVID-19, we don't have such application, but now we have so many products in this market. But make sure, but please be careful. Many of these social distancing products in the market, they only tell you the digital distance. For example, I know the two people in the photo. These two people, they are 5 pixels apart of it. They are 10 pixels apart of it. This 5 pixel, 10 pixel is defined digitally. However, according to our regulations, we care more about the physical distance, such as 1 meter, 2 meter, 1.5 meters. So we need some technology to help us enforce the physical distance about the object in the image. Okay, so as you can see from this interesting demo that I provide is a YouTube link in my slides. Okay, you can go to this YouTube link to see more the complete demo. So inside is the demonstrations. So we need to detect the human. Yeah, this is the first step. After that, we need to map and do the camera calibrations to change from a CCTV view to the bird views. With such technology, we are able to get the physical distance such as 1 meter and 2 meter, which define the physical ones. Okay, so in summary, so computer vision techniques can help us to automate the process to do the social distancing. So do you still remember in my first slides for my talk, I have 3 people that are queuing outside the restaurant, right? So I can rely on the computer vision techniques to make sure these 3 people that are queuing and at least 1 meter apart away. Okay, so far, these are some typical applications I share with you. And then next, I will share you some interesting project development which are developed by our ISS students. You know, in ISS, we have a lot of students, all of them are young talents. They develop so many interesting applications, particularly in this new normal period. Okay, so I'll give you some examples. The first example is the face masking detection. Now it's compulsory for all of us to wear the mask. Today, I don't wear the mask because I'm a speaker. Okay, so I can see 1 meter around me that no other people in my stage areas. Okay, so in this project, these students, Sarika, these are our students. He developed a very interesting system to detect the human face in the videos. So the human face has 3 categories: face with mask, face without mask, and no human face. Okay. So basically, he runs the innovative system to detect all the three different types of human face objects in the photos. Next example, hand washing. So every day we go to the office, we go back to home, we need to wash our hands. But have you washed your hand properly? Have you thought about this question? Have you washed your hand properly? Yes, so according to the WHO, World Health Organization, they have some regulations. Wash your hand need to follow 7 steps. We need to follow 7 steps to wash your hand properly. So this is a group of students, Chang He, Haihan, and Zhang Le. So they develop these very interesting applications. So based on the camera from a top view, they can analyze and recognize your hand washing actions. To make sure you exactly follow the regulation of WHO, you need to wash your hand by these 7 steps. Okay, so it's a very interesting applications. Okay, next one, exercising. So all of us working home, right? So I think many of us already gained the weight because more delicious homemade food, right? But we still need to do exercise in the home. Okay, so how to do exercise in the home? Okay, so I have 2 examples. Okay, so first examples. This is one student, Lin Ce, he's our student. He do this exercise. So we put one camera in front of him. So the camera we mount it on some tripod. So the camera look at side view. Then what the camera is doing, actually is analyzing the posture when you do this exercise. If you have correct posture, then it's okay. If you have wrong posture, it's very dangerous. You might get injured. How to recognize posture? We run the computer vision techniques, detect the human body, detect the body contours, then recognize whether your human body, particularly on your back, whether it's straight or whether it's a curve. If it's straight, that means the correct. So I visualize the green color in my photo. If it's wrong, if it's not straight, that means wrong posture. So I visualize the red color in my photo. Okay, so now you can see the red color. Okay, so it's very interesting for to exercise. So the AI, the computer vision, will be the intelligent assistant to help you to do a correct exercise at home. Okay. The second example is, for the AI, the data analytics, we sit in front of monitors every day. So then our neck is not very good, right? So we need to do some exercise. So this system will help us to monitor how long you already sit in front of monitors. If you stay maybe 1 hour, then it's time for you to do the exercise. Also, they have this very interesting small man logo to indicate the patterns. To follow the patterns, turn left, turn right, turn up, clockwise to all these different types of exercise. So this is developed by a group of people, the David and the Yazhi. I think it's very interesting for all of us to do exercise. So in summary, computer vision techniques will be the smart, intelligent assistants to help us to do the exercise in the home. Okay, so this will be some interesting application developed by our students. But now you may wonder, how to learn this technology, learn the technologies, and upgrade the skill so that you can do yourself. Okay, yes, you're able to do yourself. So because ISS offers this series of courses relevant in these areas. Okay. So now please allow me to use a few minutes to introduce some relevant course offered by NUS-ISS. Okay, I put the QR code on my PowerPoint slides. You can use the phone, scan the QR code. They will direct you to the course website for all the relevant courses. Okay. So this is a series course, a graduate certificate offered by ISS. Okay, we call the Intelligent Sensing System Graduate Certificate. So inside the certificate, we have 3 courses. The first course will be the vision system course. So in this course, we build the strong foundations of computer vision fundamentals, and particularly with the 2D static image, such as classification, detection, segmentations. After we build these foundations, we have 2 vertical pillars. One is we go to the 3D dimensions, which is the spatial reasoning from sensor data, which can help us infer the 3D geometry of objects in the data. The second pillar will be the real-time audio-visual sense and sense beginnings. We analyze the video in real time to recognize actions. Also, with the help of the complementary audio data, we can do the audio-visual data sense beginnings. After you finish the 3 courses successfully, then you can do a further step to do the practice modules, to do the more exercise and more project development to integrate all the skills we learn from these 3 courses. Okay. Then after you upgrade the skill, you can find a better job. Okay. If you apply the job, there will be some job skill required in this job advertisement. So in this slide, I list down what will be the required job skills. and how we can map this job skill to our course. But certainly for today, I don't want to go to too details about these job skills. Okay, so that's it for my presentations. So I thank you to spend this almost 1 hour time. So in my talk, also I start with the introduction for computer visions. So what is the computer visions? What it can do? Basically, they help us analyze image, video data, recognize the object, identify human peoples, infer the 3D geometrics, understand expressions, actions of the human object. Then next, I show you the recent advance, particularly in the new normal periods. So computer vision can help us into a lot of potential industry applications by monitoring, contact tracing, social distancing. After that, I show you some interesting students projects. So if you come NUS-ISS to study this course, I believe you also can do a similar thing or even better things, such as hand washing, face masking, and exercising at home. Okay, so thanks for your time. Now we still have a few minutes for Q&A. So now we move on to the Q&A session. I will answer your question. If you have any question, you can put in the Q&A session in the webinar. Then lastly, don't forget there's a QR code in my slides. Okay, scan the QR code, fill in the feedback, then you can get the PowerPoint slides. Okay, thank you very much. So now we move on to the Q&A sessions. If you have any question, you can post on the Q&A panels, okay? Okay, I will try my best to answer as many questions as I can, okay? Okay, there are so many questions. Okay, let me look at first one. Will be any recording upload after the festival for other reference? I think for this question, our colleague will help you to answer. Yeah, I will clearly help you to answer whether there any recording available online. Okay. Second question, how will you get internship under you? Okay, I suppose you want to get some collaboration with ISS, right? So I think you can go to our website. We have a lot of relevant courses. Okay, then we have a master program. Okay, so I think for that you can you have a chance and opportunity to enroll in our program as students. Then we have a chance to work together. Okay, thank you for your interest. Next question, can audio recognition be used to identify a person's emotion state? Yes, this is a very good question. Okay. Yes, we can do that. Based on the audio, we can recognize the emotions. For example, if I'm very happy, I'm happy to see. If I'm not happy, thank you. You can see I have a different emotion when I do the talking. But don't forget, audio is one of the data to recognize emotion. So I think the better way is to apply both audio and the vision data together. So they are complementary data to help each other so we can do more accurate emotion recognition. Okay, so that's my suggestion. Yes, you can do audio recognition, but it will also be good to consider both audio and video data together. Okay, next question. Is there a link for the course and how to register? Yes, if you go to our ISS website, you can see the list of all the courses. Then for every course, you can see what will be the date for future run, who will be lecturers to teach this course, what will be the prerequisite. Don't forget, for all the courses, I have prerequisite. Then what will be the topic covered for each course, what will be the learning outcome for each course. So all the information are available in our course website. Okay, I think it would be good to just go to our ISS website. You can take. Also, I think our website have search functions so that you can search some relevant course based on your interest. Okay. Yes, our colleague already helped you to provide the link for our website. Okay. Next question is very specific question related to one of the demo during my presentations. So the question is, what is accuracy in visual detection such as exercise being done correct? Okay. So I think you refer to the gym exercise, which is the last demo developed by students. Okay. So for that, I think it's quite good. Quite good means at least 80 or 85% accuracies for the controlled environment. When I say controlled environment, that means in your home or in a gym, you stand in front of some clean background, then the camera only look at you. There's no other people disturb the camera system. Then based on that, is for this control environment with the good lighting conditions, then this exercise recognition, I think is quite good, maybe 80 or 85% accuracy. So these are some numbers I can share with you. Okay, thank you. Okay. Yes, referring to, yes, I already answered a question. Yes, referring to demo, yeah. Okay, next question. How is the students demo convert to the industry use case? Okay, I think this is a very good question. So first, when we decide to such project, so we don't do this based on our own, the brainstorming, we create a story ourselves. Actually, all our projects are motivated by actual industry use case. So because we believe this is very useful in the industry use case, then our students can do some development. But after that, for follow-up stations, yes, we need to rely on the collaborators in the industries. Then we can work together how we can commercialize this, how to use it in the real deployment. Okay, I think yes, if you are interested, we can talk more offline for any this collaboration opportunity. Yeah. Okay, next question. Under the stackable program, are we allowed to cross-stack AI modules with data science modules? Okay, I think for this question, the correct person should be our program chief or colleague to answer you. But based on my knowledge, I think no, you are not allowed to do this cross-track. That means your AI system, you only can step for AI degrees. For data science, you only can step to AI for the data science program. You cannot do this cross-track. Okay. Okay, next question, also very interesting. So how about the combined audio and visual data capture to check against digitalized manual fault limits, like leakage within the limits? I think you refer to some machine defect detection in the manufacturer. Yes, we can do that. For the machine, we can deploy the microphone to extract some audio sound about the machine. That means how the machine operates. For example, aircon has aircon sound, right? Boom, boom, all these sounds. So then for the vision, we can detect any leakage outside the pipeline. Also, that means we combine both these two data. We can do this machine defect detection automatically. I think that will be useful for your predictive maintenance. So can tell you whether your machine need to do some maintenance or not. Okay, yes, I think it's very interesting. Okay, I think that's almost all the question I have. Okay, I already tried to answer almost all questions. Yeah. Lastly, thanks for your time. So please stay with us for the next very interesting talk. Yeah. Okay, thank you very much.